Rahim, in the name of Allah, the most gracious and the most merciful. Today, the topic of my presentation is coordination compounds and ligands. It is presented by me, Ikra Aftab, and my roll number is given, and I'm a student of chemistry. In this lecture, we will see what are coordination compounds, some important terms, and what are ligands. So let's go towards the introduction. A coordination compound is a compound in which a central metal ion or atom is attached to a group of surrounding molecules or ions by coordinate covalent bonds, where one atom contributes both electrons to the shared electron pair. So in a coordination compound, the first metal or the first atom that we have is a central metal ion. So in the center we have a metal ion that is present. Let's just relate it with the example that's given. In below you can see that the metal that is present is cobalt. So cobalt is the central metal ion or the atom, and this metal atom is further attached with the surrounding group of molecules or group of ions, and the bond which is present between the metal and these ions or molecules that are surrounding is a coordinate covalent bond. Now, what is a coordinate covalent bond and a covalent bond? The difference is that in a coordinate covalent bond, the electron pair is shared, not a single electron, but an electron pair is shared. One atom gives both the electrons or one pair of electrons towards the metal. In the following example, the cobalt is the central metal ion or the central metal atom, and its three, which are present 6, are the surrounding molecule, and the whole we have is 3 as chart. So you can see that our metal atom is present in the center, and the ions and the molecules are present, which are surrounding these molecules, is present on the sides. So that's how a coordinate covalent compound is formed. So what we studied the first thing is that there should be a coordinate covalent bond between the metal and the surrounding molecules, whatever they are, ions, atoms, doesn't matter. And we have seen that in the center there will be metal. And another thing is that one atom will contribute, whether it's metal, whether it's molecule that is surrounding, they will give the electron pair as a whole. Not a single electron, but an electron pair. Let's see the uses found in biological systems. Now, the coordinate covalent compounds are present in biological systems. For example, hemoglobin, used in catalysis and medicine. For example, cisplatin, hemoglobin, cisplatin. Here we can use the coordinate covalent compounds. In dyes, the coordinate covalent compounds are used, and in metallurgy. They are essential for transition metal chemistry. Transition metal chemistry is a branch of chemistry in which we study the transition metals, because in coordinate covalent compounds, metals are present. So that's why it is linked with the metal. That's why it is studied in transition metal chemistry. There are some key terminologies that must be kept in mind when studying coordination compounds. The first terminology that is present is the ligand. What is a ligand? A ligand is a molecule or ion that can donate a pair of electrons. For example, in the previous example we can see we have NH3. So NH3 has the ability to donate the pair of electrons. That's why it acts as a ligand. So the condition for a molecule to be as a ligand is that it should donate a pair of electrons. If a molecule is not having the ability to donate a pair of electrons, for example, we can say hydrogen. Hydrogen has only one electron, means that it does not have a pair of electrons. So hydrogen cannot form a coordinate compound. Because cannot act as a ligand. Basically, let's go towards specifically, it cannot act as a ligand because it cannot donate a pair of electrons. Donating a pair of electrons is essential. For example, we can say that chlorine, Cl negative, can donate a pair of electrons, hence can act as a ligand. In the following slides, we will see some examples when we will understand how to name these coordinate chlorine compounds, then we will see some examples of the ligands and the metal ions. Next terminology is the coordination number. Determining the coordination number is also important. It is the number of ligands, donor atoms bonded to the metal. If the metal is bonded with 5 number of ligands, so the coordination number is 5. Let's go towards the previous example. Cobalt is bonded with 6 NH3, so its coordination number is 6 because 6 amines are present. So the number of ligands which are donor atom, because they are donating a pair of electrons that are present, tells the coordination number. If 6 ligands are present, as in the previous example, then the coordination number will be 6. Central metal atom and ion. I have told you before that the central metal, in coordination compound, the atom that is behaving as a metal and it is present in the center is usually a transition metal. Next we have is coordination sphere. Central atom plus ligands. Coordination sphere is actually the brackets, square brackets that we use, and inside the brackets we have the central atom and the ligands that are directly attached to the central metal atom. In this example you can see the square brackets. This is the coordination sphere, and the amines and the cobalt, they are linked together, so they are present inside the coordination sphere. So it means that coordination sphere includes the central atom also and the ligands also. Okay, when talking about ligands, we have some types of ligands. First one is monodentate ligand. Remember that when we are talking about donating the electron, it's not a single electron, it is always a pair of electrons. So monodentate has one donor atom. It means that it can donate. It means that one donor atom is present, means only one atom will donate a pair of electrons. For example, Cl negative and NH3. Second one is bidentate. In bidentate, there are two donor atoms, means that in this molecule, in this type of ligand, there will be two atoms that will donate the electron pair. Means a total of 4 electrons will be donated because two donor atoms are present. Next we have polydentate ligands. In polydentate we have more than 2 donor atoms, mean like EDTA. That means that there will be more than 2 donor atoms, like 4 or maybe 6 donor atoms that will donate the pair of electrons. The main thing that must be kept in mind is that pair of electron is being donated, not a single electron. Naming the coordination compounds. Now we have seen the coordination compound. How are we going to name them? Name ligands first, then the metal. First you will always name the ligand, then you will name the metal. Ligands are listed alphabetically, not by charge or number. You have to see the names of the ligands and you have to arrange them alphabetically. For example, if we have amine and we have chloro, so amine will come first, chloro will come later, because chloro starts from C and amines begins with A, and alphabetically A comes first. That's why the ligand that is prioritized firstly as alphabetically will be named first. Use prefixes to indicate the number of each ligand. If we have more than one ligand, like if we have 2 ligands, we will add prefixes like di. For example, we have 2 chlorine, we will write dichloro. If we have 4, we will write tetrachloro. So you have to use the prefixes to tell how many number of ligands are present. Metal name ends with. Remember that metal name ends with an original name, like cobalt will end with cobalt if it is the cationic part. Actually, there are 2 parts in a coordinate covalent compound. One is the cationic part and other is the anionic part. So first we have to determine that is our metal is present in the cationic part or if our metal is present in the anionic part. If our metal is present in the cationic part, then we will write the metal name as it is, like original name cobalt. But if our metal is present in the anionic part, means having a negative charge, then the metal name will end with ate. For example, cobalt will become cobaltate. So the name of the metal matters. You have to make sure that you know that whether the metal is the cationic part or the anionic part. Also remember that we have to write the oxidation number after writing the name of the metal, and to find the oxidation number you have to find the oxidation number of other elements, and then you can have to balance the coordination sphere's oxidation number, and outside the coordination sphere then you can find the coordination number of the oxidation number of the metal. When naming the ligands, there are some names that are changed, like water is not water, it's aqua, NH3 is amine, CO is carbonyl. So these are the ligands that are neutral, having no charge. They are named accordingly as I have given. Anionic ligands ends with O, like Cl negative is chloro, Cn negative is cyano, and OH negative is hydroxyl. So you have to end the anionic ligands which is having a negative charge with O. So chlorine becomes chloro, cyanide becomes cyano, and hydroxide becomes hydroxyl. Prefixes for ligands number. As I've told you that you're gonna add the prefixes if the number of ligands is more than 1. 1, the prefix used is mono. For 2, it's di. For 3, it's tri. 4, tetra. 5, penta. 6, hexa. That's the common thing, you know that. The different thing that is if the ligand already has a prefix, like ethylene diamine. So in the ligand name is already having the prefix of di. So what you'll do, you will use another prefixes like bis, tris, tetra, kis. Now we have 3 ethylene diamine in the following example. So we wrote tris ethylene diamine. We didn't use tri because one of the prefixes from the first line was already present in the ligand's name. Then we wrote the metal name, and then we wrote the oxidation number, and then the ion. Oxidation state of the metal. As I've told you, we have to write the oxidation state also. They're shown in Roman numerals, calculated from ligand's charges and overall complex charge. 2 things must be kept in mind, that what is the charge on the ligand and what is the overall complex charge. Let's solve the following example. How many ligands we have? 6. So we wrote hexa. The name of the ligand is cyano because our ligand is anionic ligand, so we will end it with O. It becomes cyano. Then we have iron, ferrous, which will end with 8, so it becomes ferrate. How to find the oxidation number? Cn, which is a ligand, has the oxidation number -1. As we have 6 cyano groups, so 1 will be multiplied by 6, -1 will be multiplied by 6, and we get -6 is equal to -4. -6 goes towards the -4, it becomes +6 -4. Subtracting 6 from 4, we get 2. It means 2 is the oxidation state of the ferrate. That's how you can find the oxidation number. And when you find the oxidation number, you have to write it in the round bracket. Okay? That's how you name a coordination compound. Let's see some examples. The first one we have. First we'll see which is the anionic part, which is the cationic part. Cl3 is having a negative charge. It is the anionic part, so the inside will be the cationic part. First name the ligand 6 ligands are present, so hexaamine. Cr is chromium. Oxidation number as amine is neutral, so it is 0. Cl is having 3, so chromium will also has 3. And Cl is named as chloride. Next is a neutral molecule. Let's name the ligand. 2 amines are present, so we wrote diamine. Another ligand is chloro, dichloro. And then we have platinum. 2 is the oxidation state. Amine is having 0, neutral molecule. Cl negative. Cl is having -1 multiplied by 2 -2. So platinum will have its converse +2. Third example, let's name the ligand first. 3 ligands are present, trioxalato, cobaltate. 3 is the oxidation number, and as it is having a negative charge, we will end it with the ion, name as ion. Whenever we have a neutral molecule balanced, you don't end it with ion, but if a molecule is having a charge like negative or positive in the end or in the outside of the coordination sphere, you write ion at the end. So what we have seen in this lecture, coordinate covalent compounds, we learned that the bond which is mainly present is a coordinate covalent bond. Metal acts as a central metal, and the electron that are shared is always a pair of electrons. Then we saw how we name the coordination compounds, types of ligands. We have bidentate, monodentate ligands, polydentate ligands. They are named on the basis of how many donor atoms they have. We saw how we'll name the coordination compound, and we've seen some examples. Today's lecture was very beneficial from all overall point of view. That's all. Thank you.